Question 7a, Roman figure 1. Using a scale of 2 cm to 1 unit on both axes on the same graph sheet, draw the graph of y minus 3 over 4s equal to 3 and y plus 2s equal to 6. Here we have the graph of simultaneous linear equations. Roman figure 2, from your graph, find the coordinates of the points of intersection of the two graphs. That gives the solution. Roman figure 3, show on the graph sheet the region satisfied by the inequality y minus 3 over 4s greater than or equal to s, greater than or equal to 3. Solution. To plot the graph, you need to construct the table of values, and in doing that, you must note that y is the dependent variable and is always made the subject of the relation. After that, the values of s are always given, but when they are not, you need to assume a reasonable range. For this problem, I'm taking y values from minus 3 to 4. That is minus 3 less than equal to s less than equal to 4. For the first equation, which is this, you need to make y the subject by simply transferring this term. If you do that, it becomes this. Already, values of s are from minus 3 to 4. To get y value, you simply need this term because plus 3 is a constant. So you have 3 over 4s. When s is minus 3, 3 over 4s becomes 3 over 4 times minus 3. To one decimal place, you have minus 2.3. You do that for the rest values of s. 3 is a constant, and as such, you write it under each value of s. To get y values, you simply add the columns in green. That is this, you have 0.7. If you add this, you have 1.5, and so on. So this is the table of values 1 for the first equation. Second equation, if you also make y the subject, you have y equal to 6 minus 2s. The range of values of s remain the same. To get y value, all we need is this, since 6 is a constant. So you start with 6 and write it under each value of s. To get minus 2s, you multiply each value of s by minus 2, and you have 6, 4, 2, and so on. If you add 6 and 6, you have 12. You add 6 and 4, you have 10. You add 6 and minus 8, you have minus 2. After this, you plot the various graphs respectively. So you have the given scale. The scale given in the question is 2 cm to 1 unit on both axes. But if you check the second table of values, one of the values of y is 12. So if you go by that scale, you cannot get 12 on the graph sheet. So the scale is adjusted to 1 centimeter to 1 unit on y axis. The scale simply implies that one line is 0.1 units on S axis. The scale implies that one line is 0.1 units on S axis and 0.2 units on Y axis. By now, you should know how to get this. So let's plot the first point. Minus 3, 0.7. So this scale now, here is 1, so this is 2, you have 3 here, you have 4, and this is 5. So you have minus 3. But what happens here is that not all the values I plotted the values that are even, so that you can locate the points correctly. No, minus 1 is against 2.2 for y, so 2.2 is at this point. Now if here is 1, here is 2, and one line is 0.2, so after 2 the first line is 2.2. So you have it here, although there's no minus 4 in the table of values, but if you take s as minus 4, y becomes 0. You can check that in the first equation. So you plot that point directly on the s axis. Now let us take this point. When s is 0, y is 3.0. That is exactly on the y axis. Let's jump to this point. It's an even number. When s is 1, y is 3.8. So after 3, you count about 4 lines up, because one line is 0.2. So you have it at this point. When s is 4, y is 6, because you cannot locate these points directly. So we jump to 4. At that point, y is 6. That is somewhere here. The next thing is to join the points together and plot the second equation. Meanwhile, this is the equation that you have plotted. It becomes the title of the graph for now. After the second one is plotted, you update the title to reflect the two equations. For the first equation, all the points have been joined together. So we plot the second equation, which is this, with the second table of value. Minus 3 is 12. This minus 3 is for s. You have 12 somewhere here. Minus 2 for s, 10 for y. That is somewhere here. Minus 1 against 8. That is this point. 0 against 6. When s is 0, y is 6. You plot that point directly on the y axis. When you have 1 for s, y is 4. That is somewhere here. When s is 2, y is 2. When s is 3, y is 0. You plot that point directly on the s axis. When s is 4, y is minus 2. That is somewhere here. After that, you join all the points together and get the coordinates of the point of intersection, which becomes the solution to the two equations simultaneously using the graphical method. So here, the points from the second equation has been joined together, and you have this as the point of intersection. If you trace that point down, it is one line after 1. That is 1.1. that is S. Then for Y, this point is 4 and here is 3. Remember, on the y-axis, one line is 0.2 and it is on the fourth line from 3, that is 3.8. That is the coordinate of the point of intersection of the two graphs. Roman figure 3, you are to show on the graph sheet the region satisfied by this inequality. Here we simply get the intercepts on both axes. To achieve that, you change this sign to equality sign. To get the intercept, you let s equal to 0 and you solve for y. If you let s equal to 0, here becomes 0. It means y is equal to 3. And you let y to be equal to 0 as well. If you solve for s, you have minus 4. So you have the other points. So this is 1 point already. So you see why I have to include this minus 4 from the beginning. Alright, so when y is 0 here, s is minus 4. And this point, when s is 0, y is 3. That is what you have here. The line is thick because you have weak symbol of inequality. If the symbol is straight, you use broken line. This greater than or equal to means the region above satisfy the inequality. You shade the region above because of the greater than that you have there. Greater than region above. Because of the equal to attached, you use a thick line to represent the inequality. Question 7b. Given that s squared plus bs plus 18 is factorized as this, find the values of c and b. We need to factorize this equation. Then you compare coefficient of s squared, s, and constant term as the case may be. Alright? So if you factorize this equation by expanding, because it has been factorized already, what you need now is to expand. If you expand, you get this result. Now this is cs, this is 2c. That means c, okay, that this is the constant term. Constant term. We look at cs and 2s. These two terms cannot be added, but you can factor out s. You factor out s, you have s plus 2. Next thing is to compare this result with this one. There's no term to compare in s squared. We simply move to bs, and that is the middle term. The middle term, alright. The middle term, you are going to have b equal to s, that is c plus 2. b equal to c plus 2. But if you start from the constant term, you can get c first. So if you compare the constant terms in both results, they are equal. So you have 2c equal to 18. Divide through by c. Divide through by 2. c is equal to 9. If you put 9 here now, 2 times 9 is this 18. You see why they are equated together. If you compare the term that contain s, this is bs, and you have s into c plus 2, you have it that b is equal to c plus 2, or c plus 2 is equal to b. And what is c? 9. So 9 plus 2 is equal to B. Therefore, B is equal to 11. This is how you deal with problem like this. Peter calls simplified maths. If you are watching and viewing from YouTube, don't forget to subscribe, like and share PSM videos. If you are watching and viewing from Facebook, follow and like the page for more updates. Also share PSM videos.